Hello and welcome to lesson 4B, more exponent rules. In this lesson, we're going to look at harder exponent problems, basically. So if we have 4xy cubed to the squared power, what that really is, well, x to the fourth is 4x's, y cubed is 3y's, and we're going to square it, so we multiply it by itself. And when we do that, what we end up with 8 x's, so I get x to the 8th and 6 y's, y to the 3rd. And then similarly, let's also look at this if we had division. If I had x to the 4th over y squared all cubed, well, I'm going to write that out in log. And what I really get after writing this out, when I count these out, I end up with x to the 12th over y to the 6th. And if you notice, what's really happening is that exponent is multiplying both of those interior exponents. So if we have ab to the m, that's the same thing as a to the m times b to the m. Or it's same thing with division. If we have a over b to the m, we raise both of those to that power. So let's practice these. If I have 5x to the 4th all cubed, this becomes 5 cubed times x to the 12th. And then 5 cubed is 125 x to the 12th. 3/4 all cubed, we raise both powers to a power of 3. This would be 27 over 64. Down here, we're going to square everything. Well, 5 squared is 25. Y to the 6 times 2 is 12. Over n to the 2 times 3 gets me n to the 6th. Here we have a negative power. I'm going to go ahead and multiply that out. I get 2 to the negative 3 times negative 2 is positive 6 over y to the negative 2. This guy can now come up here, so I get 2 to the 6th y squared and and we could actually go ahead and evaluate 2 to the 6th to get 64y squared. Now here I'm going to take this fifth power and I'm going to send it to all of these pieces in here. So I get a to the negative 20, b to the 15th, and c to the negative 10. Anything with a negative exponent needs to flip. So we have b to the 15th over a to the 20th, c to the 10th. Now this fourth power is going to go to all three pieces. Well, 2 to the 4th power is 16. Then I have a to the 5 times 4, which is 20, over b to the 7 times 4 is b to the 28th. Now I want you guys to try these 4 problems on your own. Go ahead and check your work. And try these 2 other problems real quick. And check those 2. All right, when we have variables in our exponents, all of our rules still apply. So if I have n to the x times n squared, we still are going to add those exponents. So this becomes n to the x plus 2. Similarly here, we're multiplying, so we're going to add our exponents. This becomes m to the 2x minus 1 plus 5x plus 2, which gets me m to the 7x plus 1. Here we're dividing, so we're going to subtract our exponents. This becomes x to the 2k minus 5. And here, I am first going to simplify what's in here first and then deal with this. When we divide, we subtract our exponents. So this becomes e to the k plus 3 minus parentheses 4 minus k, all to the 2k plus 1. We'll come back to that guy later. I put this in parentheses because that minus applies to both of these things. So what happens now is we get e to the k plus 3 minus 4 plus k, all to the 2k plus 1. Ooh, hello, stop. 2k plus 1. Then we're going to combine our like terms. I get e to the 2k minus 1, now raised to the 2k plus 1. And at this point, I'm going to multiply my exponents. This becomes e to the 2k minus 1 times 2k plus 1. When I FOIL that out, guys, it's one of our special patterns. This becomes e to the 4k squared minus 1. All right, guys, I want you now to do these 4 problems on your own. All right, go ahead and check your work. Okay, Now, there is a way to help us remember what to do, and we use PowerMan to help us do that. And PowerMan stands for the following. So PowerMan do something stands for power, multiply, add, nothing, divide, subtract. And what this says is it tells us how to deal with both our coefficients and our exponents as we're working through a problem, and they go in pairs. So here, if I've got a power problem, that means I'd have something like 7x squared to the third power. What I'm going to do is the top always refers to what I do with my exponent. I'm going to raise my exponent to a power, and then I'm going to multiply the exponent. So this guy would become 7 raised to that third power times x to the 2 times 3, which is 6. So power problems, we send the coefficient to a power, we multiply the exponents. Next, when we have a multiplication problem, we're going to add our exponents and multiply our coefficients. So this would be like if I had 3x squared times 4x cubed. What I would do, I would multiply my exponents, 3 times 4 is 12, multiply my coefficients, and then add my exponents. I'd get x to the 5th. Then next, when we are adding, we do nothing. So this would be like if I had 3x squared plus 5x squared. Those are like terms. We add the coefficients. That would be 8. And then nothing happens with the exponents. They stay the same, 8x squared. And then last but not least, when we divide, we subtract our exponents. So if we had 12x to the 5th over 4x squared, we divide my coefficients to be a 3, and then we subtract those exponents, x to the 3rd. So that's a little mnemonic to help you guys. PowerMan do something. So that's how we deal with single things happening. Now let's talk about what happens if we've got a more complex situation. If we're working with exponents and the coefficients and the exponents are always treated differently, the operations of the coefficients matches the structure of the problem, and the operation on the exponent is one step down the PowerMan chart. So let's review the PowerMan chart. When simplifying problems involving multiple exponent rules, 1, I want you to always apply any powers that are outside of the parentheses first, and then drop the parentheses once you do that. After that, I want you to move any variable that has a negative exponent so that it is where it belongs. And once you move it, you remove that negative on the exponent when you relocate the variable. Then you're able to simplify your coefficients, treating them as a fraction to be reduced. And then you're going to simplify each variable independently. And always ask yourself, where do I have more? How many more? What else could I do? So let's take a look at example A here. So again, the first thing I want to do is I want to apply any powers. So this power outside is going to go to all 3 pieces here. So this becomes 5 to the negative 3rd power, x to the negative 3rd power, and y to the positive 12th power. Great. Now we're going to move any variable that has a negative exponent. Well, that would be these 2 pieces here. So my y stays in the numerator because it has a positive exponent over 5 to the 3rd, x to the 3rd. And now I'm going to deal with my coefficient. Well, 5 to the 3rd is 125. So I have y to the 12th over 125 x cubed. And at this point, I'm done. I've only got one of each variable. There are no negative exponents. I'm done. Let's look at this guy. First, we're going to apply the outside power. So we do that to get a to the negative 6 times negative 4 is positive 24 over a to the 12th. And now I don't have any negative exponents, but I can simplify. We have a division problem here, so we can subtract. I get a to the 12th. Moving right along. Here's some more problems. Now here we've got 5, 6 to the negative 2. I'm first going to deal with that negative 2 power. I get 5 to the negative 2 over 6 to the negative 2. Now we deal with our negative exponents, which means we're going to flip these guys. I get 6 squared over 5 squared. Now we deal with our coefficients. That's 36 over 25, and there is nothing else to do. We're done. Let's look at this next guy. There is no overarching power, no power to power in this, so we're going to go ahead and deal with all of our negative exponents. So here, The u to the 5th is the only thing that stays in the numerator, and then that u to the 9th is going to come up to join it. Then in my denominator, the 7 squared fell, as did the e to the 8th, and that's joining the e to the 3rd that was already down there. And now we're going to use our exponent laws to simplify. U to the 5th times u to the 9th gets me u to the 14th over 7 squared is 49, and then e to the 8th times e to the 3rd gets me e to the 11th. And we're done. Nothing else can happen. Coming on down here, we do have a power outside, so we're going to deal with that guy first. I get 4 to the negative 2nd power, then x to the negative 10th power, and y to the negative 2 power, over. Here we get y to the negative, positive, it became positive, positive 8th power, and then z to the negative 2 power. Now let's move anything with a negative exponent, which is almost everything. So everything moves from the numerator, moves to the denominator, but that z to the negative 2 comes up to the numerator. And in my denominator, we had the y to the 8th we started with, but there's also now a 4 squared, an x to the 10th, and a y squared. So let's now combine some like terms here. We have z squared on top, and then 4 squared is 16. I'm moving that to the front. Y to the 8th and y squared becomes, and we also have x to the 10th. And I probably should have written those reversed, but it doesn't matter that much. So that's your final answer. Nothing else can happen. Now this guy, let's deal with our powers first, our outside powers. That 3 is going to go to all of these pieces in here, including that 5 and that negative 2. So this becomes here 2 cubed x to the 12th over 5 cubed y to the negative 6th. And now let's look at the other fraction. We've got that negative 1. It's going to go to all 3 pieces. So times. This becomes x to the positive 4 with the negative 1 over 10 to the negative 1, and then y to the positive 2. Now let's take anything with a negative exponent and move it. I'm also going to go ahead and simplify my, my coefficients here. So we have 8x to the 12th, and then that y to the 6 comes to the top, over 5 cubed is 125, times that 10 to the negative 1 comes to the top, which is 10, and then nothing else moves in this fraction. X to the 4th over y squared. I don't know why I'm getting such a delay in the pin, guys. I'm sorry. At this point, I am going to start combining these. The 125 and the 10 can reduce because there's a 5 in each. This would leave a 2 and a 25. And I'm going to go ahead and combine anything that can combine with, or my x to the 12th and my x to the 4th can combine with addition. So here we have 8 times 2 gets me 16. X to the 12th and x to the 4th gets me x to the 16th over, we have the 25. Now, if you look at this, we have a y to the 6th in the numerator, a y squared in the denominator. I can subtract those because they're really dividing each other. So I get a plain y to the 4th in my numerator. So there's that question. And let's take a look at G now. Here we have 2a, x to the negative 2a times 3a all to the 3rd. I'm going to first apply that 3rd power. Ooh, I don't know why that just jumped. First apply that 3rd power in here. So I have x to the negative 2 times 3 cubed, and then x, ooh, sorry guys, it's an x. Don't know why my pen is being so slow. X to the 3a, and now I can combine 3 cubed is 27, and then I add my exponent since we're multiplying here. I get x 3a plus negative 2a is going to just give me x to the a. Here, we're going to first do power to a power here. So I get y to the 9c over y to the 4c minus 3. Because I'm dividing, I'm going to subtract my x. This becomes y minus, put in parentheses, guys, otherwise you'll make a mistake. We distribute that negative, so I get y to the 5c plus 3. Being careful with that negative. Please show up. 3. There we go. All right, guys, this is the last section here. I want you guys to go ahead and answer these 4 questions, and then you'll be done with the video. Thank you guys so much. Okay, go ahead and check your answers. All right, guys, go ahead and take a look at the practice, and good job.